Good morning to Dr. Sharifah Masliha. Today I would like to present the problem definition and objective for our project, which focus on the application of mesh analysis in electrical circuits. So first of all, I would like to tell you about the problem definition. In many real-life electrical systems, such as portable power banks, car electronic wiring, and electronic kits, a single power source, usually a battery, is often used to supply power to multiple devices at the same time. However, each device has different current requirements. If the current is not properly distributed, it can lead to several problems such as overloading, component damage, and reduced system efficiency. In this project, the main problem we address is how to analyze and control the current distribution in a circuit where two devices are powered by one battery. Since the circuit consists of multiple loops, the current flowing in one loop can affect the current in another loop. With the proper circuit analysis, it becomes difficult to determine the exact current flowing through each device, and this may cause the system to operate beyond its safe limits. So next, I would like to propose a solution for this problem. To solve this problem, we apply mesh analysis. Mesh analysis is a system method of circuit analysis that uses Kirchhoff voltage law or KVL to calculate the current in each loop of a closed circuit. This method is especially suitable for multi-loop circuits with shared components, making it ideal for analyzing real-life electrical systems like the one used in this project. So next, I will tell the objective of this project. First, to apply mesh analysis in determining the current flowing through each loop and each device in the circuit. Second, to verify that the current supplied to each device meets its required value without exceeding safe operating limits. Third, to prevent overload conditions by analyzing voltage drops and current sharing within the circuit. And the last one is to demonstrate the practical relevance of mesh analysis in real-world applications such as portable power system and automotive electrical circuits.
For today, I will be presenting for the circuit design. This circuit implements mesh analysis to solve a power distribution problem involving two DC sources and 5 resistive loads. It simulates the internal power management of a hybrid device such as a solar integrated power bank. For the component selection, by using Tinkercad, the circuit is constructed on a standard breadboard using the following components. For the power source, we have two voltage, one is primary and secondary. For the primary voltage, a 9-volt DC supply representing the main battery pack. For the secondary voltage, a 6-volt DC supply simulated by 4 1.5 AA batteries in series representing a secondary solar charging input. For the resistive network, 5 resistors which are 220 ohm, 330 ohm, 470 ohm, 100 ohm and 560 ohms are arranged to create 3 distinct current loops, which are known as mesh.
And I will be explaining about simulation results. This simulation is to prove that mesh analysis can be used to calculate current flow when there are multiple battery sources. And in this case, 6 volt and 9 volt is used. After running the simulation, we get that current flow through R1 is 21.8 mA and the current flow through R2 is 12.6 mA, while the current flow through R3 is 9.15 mA and the current flow through R1 is 1.29 mA, and finally current flow through R5 is 10.4 mA. If we compare this to the theoretical value, the percentage error is less than 2%. The slight deviation in this is because the number of decimal places that we use, which is 3 decimal places at most. Otherwise, this proves that mesh analysis is effective in finding current flow when multiple power source is used. Anyway, that's it for now.
For the reflection part, our project help us understand how mesh analysis work in a real circuit with a multiple loop and share components. By supplying two devices from one battery, we learn how current is distributed and how theoretically calculation closely match the simulation result. The small difference between calculated and simulated value show that the analysis was accurate and the circuit worked as expected. For future improvement, our circuit can enhance by building it using real hardware instead of only simulation. So real-world effect like component tolerance can be observed. Protection components such as fuse or voltage regulation can also be added to improve safety. In addition, using variable loads or analyzing power efficiency would make the system more realistic and suitable for practical application. Thank you.